This problem is really similar to the last one. I am given a information about a function right here, and asked to build a Taylor series. This is different from the last one in that previously I had x equals 0, and now I have x equals 1. So essentially what I'm going to do is change everything from my last video where there was an x to an x minus 1. That gives me that I'm going to write p sub 3 for the third degree polynomial of x is equal to f of 1 plus f prime of 1 times x minus 1. I'll point out that this part of the series right here is nothing but point slope with a tangent line. If I took this guy over here and change that to a y, it would be point slope for a tangent line. So the next terms that I get are plus f double prime of 1 times x minus 1. Squared all over 2 factorial plus f third derivative at 1 times x minus 1 cubed over 3 factorial. So all I do is plug in all my different derivative values here where appropriate, and I get that p sub 3 of x is equal to, I get 5 minus 3 open parentheses x minus 1. Next one's positive, so I get plus 1 times x minus 1 squared over 2. And then I get plus, I got a 4 right here. It's going to get divided by a 3 factorial. So this will leave me with a 2. One of those 2's will cancel with one of the 2's in here in this 6. So I wind up getting x minus 1 cubed over a 3. And that's actually my answer for part... Sorry, wait. I'm still left with a 2 up here. So I get 2/3 there. From there, that's my answer to part A. From there, I just have to plug in 1.2. What's nice about 1.2 is for each of these x minus 1s, I'm subtracting 1.2. Well, 1.2 minus 1, that just gives me 0.2. So it's easy to just write 0.2 in for everything. So p sub 3 of 1.2 is 5 minus 3 times 0.2 plus 0.2 squared over 2 plus 2 times 0.2 cubed over 3. And then I would evaluate that, and when we evaluate that, we wind up getting 4 point, when I round to 3 decimals, 425. After that, it has a repeating 3, but I only have to be accurate to 3 decimals.